Okay, so the thing is that we need to take certain questions so that you are able to get what Henry law equation is and how it is used. I remember a question. It's about hydrogen sulfide. Let me write the question number actually. The question number is 2.6 probably. 2.6 in text question from NCERT. What this question is, it talks about hydrogen sulfide dissolved in water. Dissolved in water, and its solubility is 0.195 mole per kg, right, at STP. Okay, so what we need to find out the Henry law constant. Find out Henry law constant. There's more information about hydrogen sulfide, and that is, it has a rotten fish-like smell. Okay, and used in qualitative analysis inside the lab. I hope you understand what qualitative analysis is. In case you don't, I will tell you in some other video. Right now, let me solve the question. I repeat the question again so that I can make you go through the solution. The question is, hydrogen sulfide has a solubility of 0.195 mole per kg at STP. You have to find out the Henry law constant, and the two information in given. This is used in qualitative analysis inside lab, and it has also rotten fish-like smell. So let's do that, taking the formula. So what we understand, that first thing we need to find out that this particular value is nothing but molality. So molality is also the solubility here, which is 0.195 mole per kg. Right? I repeat again here. This represents to solubility. Remember, solubility can be in terms of mass, it can be in terms of mole, it can be in terms of mole fraction. But there it is in terms of mole per kg in molality. Okay, so this is the molality. Now, what does it mean? Number of moles of hydrogen sulfide is 0.195 mole. Because this represents this mole per kg. So this is the mole of the H2S. And what that means? NH2O is going to be 1000 divided by 18. That's going to be 55.5 mole. Let me repeat how I just solved it. Remember, this is 0.195 mole per kg. The solvent here is water, and since it's directly say that this is the number of moles of H2S and this is the mass of the water. So water is here 1 kg, where 1 kg is equal to 1000 grams, and 1000 when divided by 18, you will get the number of moles of NH2O. Okay, so let's go ahead and solve it. So what we have now, Henry law equation now. Henry law equation. This Henry law equation says partial pressure of H2S is equal to KH of H2S multiplied by JEE2. What JEE2 represent to hydrogen sulfide. Right? So partial pressure of hydrogen sulfide equal to Henry law constant of hydrogen sulfide multiplied by mole fraction of hydrogen sulfide. Let's expand it. So there we have 0.19. Sorry. There is something again here. I will tell you. At STP, pressure of a gas is equal to 0.987 atm. And it's also going to be like 1 bar. It's also going to be like 10 to the power 5 Pascal. But right now I'm using 0.987 atm. I can also use 1 bar. I can also use 10 to the power 5 Pascal, because that's exactly the same. So I'm using here 0.987 equal to Ks, that's we have to find out, multiplied by XH2O. So XH2O is going to be NH2S divided by NH2O, right, plus N H2S, NH2S. Right, this is the mole fraction of H2S, number of moles of a component divided by total number of moles of all the components. Let's take this to that direction because okay, so let's find out here. Another thing is here, I will not be using this NH2S here. I will not be using this. Why? Because every time a solution is dilute, in order to make the calculation simple and easier, you know, the number of moles from the denominator for the solute is ignored. You can use it, but this is ignored just to make sure that the calculation is simple. So what's the reason, you know, behind ignoring this? You know, because N1 is much greater than N2. So that's why the equation is going to be KH equal to 0.987 and multiply by NH2O divided by NH2S. This is what. Let's put the value. It's 0.987 multiply 55.5 divided by 0.195, 0.195. So this is what KH is going to be. Let's close this right here. And what its unit will be? Its unit is going to be ATM. Its unit is going to be ATM because this also represents to a pressure. Once you solve it, you will have the answer right here. So this is how KH is calculated for this particular question. I think I have made you lots of things about. So let me repeat it right here, and then I'll be, you know, winding this video off. As per the question, hydrogen sulfide is dissolved in water at STP. Its solubility is 0.195. You have to find out the Henry law constant. As per the equation, Henry law says P equal to KHX. So we need P, we need X. So P for any gas at a standard condition is 0.987. So we have pressure 0.987 equal to H, KH, and then X represent the number of moles upon total number of moles. So NH2S upon NH2O plus NH2S. This I have ignored because this is something doesn't affect the calculation, and this is always useful for a dilute solution to ignore the number of moles of solute from a calculation of a mole fraction. So I've ignored that. I mentioned the reason here because N1 is much more greater than N2. And after that, you know, you just place that NH2O we have here is 55.5 mole and NH2S we have here 0.195 mole. So once you solve it, that's going to be the KH of Henry law, KH of hydrogen sulfide. Right? So I would say, you know, this is how Henry law constant is calculated. Let me know your, what I would say, your opinion about, your thoughts about, and anything you have to say. I'm looking for your critical, comments. But apart from that, you can also appreciate my work if you like. So that's it. Thanks for watching. I'll see you in the next video.